Hello everyone. So today we're going to learn 13.4, which is motion in space, and we're going to learn velocity and acceleration and also the application. Let's take a look. The first subject we're going to learn is projectile motion. I'm going to give you what's the meaning of projectile motion. That means a projectile is fired at some angle from an initial position and then act upon by only the force of gravity. So if I draw the graph, it should look like this. Okay. So here we start from the easy case. We start from origin and it is 2D, okay, on the plane. So start from origin, but in the future, after we learn this, it can start from anywhere. We can fire this projectile from anywhere. Now let's take a look. We fire this projectile with some initial velocity, okay, and with some angle, for example. The angle is theta, and with initial velocity vector. Okay, and so let's see. That means we fired projectile at some angle from an initial position. So here is origin. And act only by the force of gravity. So that means acceleration is g, right? Which is 9.8. Okay, something like this. Gravity. And now let's take a look. We want to answer those questions. We want to see how far the projectile can hit the ground. For example, once it get the highest position, definitely is need to get to the ground. We want to see how far it's going to get and what is the highest position it can get, something like that. We want to answer those questions. And firstly, we need to set up the differential equation and the initial condition. So what's differential equation is like what we did before. To use the number also in the quiz, I give you we know the acceleration. Okay, so in the quiz actually that is given by d square r dt and it equals something, right? And here we have the initial velocity and the initial position, and by using those conditions we can find C1 and C2, and we solve the problem, and we call this initial value problem. Same thing here, we need to set up an initial value problem for our project motion. Now let's take a look. Okay. The differential equation for this case is what? Acceleration is what? Acceleration is just gravity, right? Just has gravity. So that means the acceleration is negative gj. Do you know why? Let's take a look at what is the acceleration. So what's the direction of acceleration? Gravity, we know is go like downward, like this way, right? And for the plane, we know this direction is I, this direction is j. So it's opposite to the direction of j. So that is negative gj, right? So firstly, because acceleration has direction, so we have to put j. It's like the force. If we move something, like this way, the force should equals to 5I or what? Scalar times I. So because it's in the i's direction, it's a vector. This has direction. Okay, this is the differential equation, and we also need initial condition. So initial condition. What's the initial condition? Initial condition we know is R initial as is given by R naught. So for this case, it's origin 0, 0. And what is dRdt? dRdt, which is also the initial velocity. So velocity, we say we not. It's kind of like in the graph, it's a vector, okay? It's a vector. So this is initial value problem. Now we are going to solve this initial value problem. And firstly, we fire the projectile with initial velocity. And here we say the velocity, the speed, the initial velocity, okay. The length of the initial velocity is, we just define that with v naught, but without v0. So, we can write down this way. So in the book, it's write down like this way, kind of like v naught. Okay, this is like initial speed. The length of magnitude velocity. Why we want to do this way? Because we want to decompose it we want to express our initial velocity. So let's take a look. Initial velocity equals what? This is vector, be careful, right? So this equals, okay, if we took a look at the graph, I'm going to write down here. So this is our initial velocity, and we have angle theta here. So we want to express this as some I plus something j. We want to write down this as vector form. Okay, so you can see the i's component should be the velocity magnitude here times cosine theta. Is that right? And the j's component should be sine velocity absolute length, which is also speed, times sine theta. And we rewrite this as just this I plus, we choose this as initial speed, sine theta j. Okay, so this is our initial velocity. And now let's take a look. We want to solve this differential equation. Okay, solve this differential equation. A is given. So let's see. A is negative gj. How do you find the vt? V equals integral of A. Is that right? So we do the integral. So it should be negative g tj and plus c1. How do you find the c1? We use the initial condition v0. Okay. So here v initial condition, okay, at time 0, which is if we plug into the vt, it's just c1, and it's given by the initial condition here, cosine theta I, cosine theta j, something like this. And then we know what is c1. C1 just equals this, sine j, theta j. Okay, and now let's plug this into our initial, plug into our velocity function. Velocity is vt, now becomes negative gtj. So because I'm looking at here, okay, and plus c1, turn c1 into v0 cosine theta I, v0 sine theta j. Okay. And be careful, here is this is scalar, right? Scalar. This is magnitude of initial velocity. speed, initial speed. So we say this is initial speed. Okay, and then we want to simplify our VT, velocity. We want to combine the J's term. Okay, we rewrite this. V0 cosine theta I plus negative GT plus V0 sin theta J. So this is our VT, velocity. But what we are looking for? We are looking for the RT. We want to solve this differential equation, right? So this initial value problem. So RT is integral of VT actually. Let's do the integral. Okay, this becomes what? This becomes, for the S term, it's going to be, this is just a constant times T, I. And here, integral we have T, so it should be 1/2 T squared, so T squared over 2. G times T squared over 2, and plus V0 sin theta T and J and plus C2. Because we did the integral and we need to put C2. And next we put, so what is our initial velocity, initial position, which is 0, 0. And if we plug in here, just C2. So what is C2? C2 is 0, 0. So the final answer RT equals this one. Cosine theta T I plus negative 1/2 GT squared plus V0 sin theta T J. So this is RT. So in the final exam, don't worry, this formula will be given. Okay, this formula will be given. So this is the position vector equation. So this is the vector equation for the position. And this is the vector position for the velocity. For velocity. Okay. Now let's take a look at the example. Okay, so in general, so I need to give you the general formula. In general, RT equals here x naught plus cosine theta I, here y naught minus 1/2 GT squared plus R V naught sin theta and times T. So here we have T here. We have T here. And J. Okay. Actually, this means, in general, means initial position is x naught, y naught. So if you plug in the initial position y naught to x naught, y naught to the C2, that is going to be C2. And if you plug in C2 into our original, you should get this one. So this is general form, start at any point x naught, y naught, initial. But if just start from origin, x naught, y naught are 0. Okay, so general position. Now let's take a look at the example. So our RT, the formula looks long, but you know there is another way to give this RT, is given by just x and y. Okay, parametric equations. So this is the vector equation, right? Vector equation. Okay, and there is a parametric equation. So just x naught equals v0 cosine theta t, and y0 equals v0 sin theta t minus 1/2 gt squared. And maybe this is easier for you to to see. This is like a short equation, shorter one. This is parametric equations, you can see. And with parameter t. And theta and v0, they are all constant, right? Theta is the angle, v0 is the initial speed, and the t is the parameter. So you can use anyone to solve the problem. Next, we want to find what's the maximum height. Okay, so what's the meaning? So when we fire the projectile, it's get the maximum height. So it's like the highest position here. Okay, and we need to know when it's get the highest position, what's the velocity at there. So velocity, equals something like I and j. So some term like should have this, right? But when you get the highest position, this term, this one need to be 0, because in the j direction, it's not going to go up anymore. It's going to stop there. So it may have some velocity like in x direction, but in y direction, the velocity has to be 0. And if we look at our velocity function, look at our velocity vector function, it's given by here. So j's component, or the y component, so it's negative gt, so it's going to be here. I just negative gt, so we make this term equal 0. Then gt plus v0 sin theta equals 0. So that means, okay, and we can write down whole thing. Vt equals v0 cosine t or cosine theta. Okay, negative gt plus v0 sin theta j. This is our vt, right? And when we get height position, this term need to be equal 0, so we set. So that means we can set this as negative gt equals plus v0 sin theta equals 0. And we can solve a t from here. T equals v0 sin theta over g. So what's this t? This t means when it will hit the highest position. The projectile hit the highest position. So after how long the time, right, is hit the position. And now this is t, and if we are looking for the maximum height. Maximum height means the y value when we get highest position. So that means y value, and now we take a look at the y value here. So y equals v0 sin theta t minus 1/2 gt squared, and we plug this t into here. So v0 sin theta, and what's t? G v0 sin theta, and minus 1/2 g and t squared, g squared v0 squared sin squared theta. And then we can simplify. This is, it's going to be g here, and v0 squared sin squared theta, because we combine them together, and then minus 1/2. And here g and this g squared cancel, we also have a g, and v0 squared sin squared theta. And you can see those two terms are the same thing, and we can combine them. So the final answer is 2g v squared sin squared theta. So this is the maximal height. We can say this is the y maximum. We don't need to memorize this formula. I will give you the example later. We can just plug in the number, so we can solve for t easily from the real problem, and just plug into our y value, and we can find the y. So you don't need to memorize the formula here. Next topic we are going to do is the range. So what's the range means? So when we fire the projectile, and it can finally hit the position, hit the ground, right? So x and y here, and from origin, and we call this the range, that farthest position it can get. So this is the range. So how to find this range? and we are going to do this way. So you can see the range actually in the RT, that is going to be the x value because it's in the x direction. And when it hits the ground, what's the y value going to be? Y need to be 0. Is that right? So y equals 0. So we would use this. We want to find the t. So when the projectile hit the ground, y value is 0. And if we look at the y value here, so y value, okay, y equals v0 sin theta t minus 1/2 gt squared. We make this equal 0, solve for t. That means when it's going to hit the ground. So solve for t, v0 sin theta, we cancel the t here, equals 1/2 gt, and the t equals actually divided by, so times 2 v0 sin theta and divided by g. And this is t when it's going to hit the ground. And next we plug into the x value, we find the range. So it's going to be x, so max value, right? It's going to be, and the x value, if we look at the original here parametric equation, x v0 cosine theta t. So it should be v0 cosine theta t, and plug this t into here, v0 cosine theta, and t is 2 v0 sin theta over g. Simplify. G is at the bottom, and here we have v0 square because we combine 2 v0, and we have 2 cosine theta sin theta. And here we use the double angle formula. We change this into sine 2 theta. So the maximum range x value, which is sin squared 2 theta over g. Okay, so this is the application of the projectile motion. By using the RT, we can find the maximal range. We can find the range, maximal distance it can travel, and also the maximal height, the highest position it can get. Now we can take a look at the example. It's a pretty easy one. Let's see. Example 2. So a projectile is fired with initial speed. So here I skip the projectile. Initial speed. So this is same thing. V0 equals 100, right? And with angle of 30. Degree, so that means theta is 30, and we want to find what? Two questions. First, second, the range of the projectile. And the maximal height. Okay, two questions. Now let's take a look at how we find the range and the highest projectile. How do we find the range? Okay, the range depends on the y maximal value, right? The y, the range, no, x maximal, but the y should be 0. Okay, so the range. Now we want to solve a t. We get the highest position. Okay, get the hit the ground. First question. Okay, the angle here theta is 30 power 6, and the v0, which is 500. We make y equals 0. So what is y? Look at the y value here. So y should be v0 sin theta t minus 1/2 gt squared, and this equals 0. We solve for t. or you can just plug in, we can cancel the t right here, so and then plug in v0 500 sine power 6 minus 1/2 gt equals 0. Solve for t. Sine power 6 should be 1/2, so here's 250. 250 times 2, so 500 over g. So this is after this time we hit the ground, the projectile hit the ground, and then find the range. Range equals x value, which is v0 cosine theta t, and v0 500 cosine power 6, and t 500 over g, and just simplify. So 500 root 3 over 2, 500 over g. And if we don't simplify, you can leave the answer like this: 250 times root 3 and another 500 divided by g. Okay, you can leave the answer like this, doesn't matter too much, but we can also use the calculator. This is the range. First question. Second question, the maximum height. Maximum height, we need to look at the VT. So VT equals v0 cosine theta I, v0 sine theta minus gt j. Okay, VT, so we make this equal 0. That means 500 sine power 6 minus gt equals 0. Solve for t. And here this is like 500 times root 1/2 sine power 6, which is 1/2. And this is 250. So t equals what? 250 over g. So after this time, we hit the height position, and then y maximum value, which is y value, so we should be v0 sine theta t minus 1/2 gt squared. This is the y, right? And then we just plug in the t. So v0 500 sine power 6 t 250 over g minus 1/2 g and t squared, and simplify. So after simplify, this should be 250 squared over 2g. So you can see here, we don't need to memorize too many formulas. We need to understand everything. The most important part is RT. So which is given by v0 cosine theta t, v0 sine theta t minus 1/2 gt squared. Okay, and what is VT? And those two formulas will be given in the exam. v0 sine theta minus gt. Okay, VT, RT. Those two formulas will be given, but for the maximal height and the range, we don't need to memorize. If you understood the problem, when is hit the height, when we hit here, y value equals 0. Okay, when it's hit here, that means v like a j's component equals 0. Right, and we can solve for t. And by solving for t, we can just plug in RT and find the final answer. Please try all the homework problems. Definitely this kind of problem will be in the final, because this is the application of the acceleration and velocity vector. And then this is very useful, very useful in real life. And in the first part, this is the first part, we can stop here.